previous video, we discussed about Coulomb's law. In today's class, we are going to start the vector form of Coulomb's law. And as we studied in the previous class, that Coulomb's law gives us the magnitude of electrostatic force acting between the two charges. Now, the vector form of Coulomb's law basically completes the value of the force, or in fact you can say, since force is a vector quantity, so a vector quantity must have a magnitude as well as a direction. So the vector form of Coulomb's law will also signify the direction of electrostatic force rather than giving only the magnitude of the electrostatic force acting between the two charges. So before we get into the detail of today's topic, let us first revise what we have already done in class 11. We have studied about unit vectors in class 11th. So what are unit vectors? Unit vector, as the name suggests, are vectors of magnitude 1 or unity, which stands for 1, and they are basically used to signify the direction with which ever quantity they are associated with. For example, we have studied about unit vectors along x-axis, which is denoted by I cap. Along x-axis it is I cap. Along y-axis it is j cap, and along z-axis the unit vector is k cap. So these are the standard notations of unit vectors which act along x-axis, y-axis or z-axis. But suppose if we are given a vector and we are asked to find the direction of unit vector or the direction of a vector which is already known, then suppose we are given vector A and we have to express a unit vector in the direction of A, then the unit vector in the direction of A will be represented by A cap, which will be written as vector A divided by its magnitude. You can make a note of this, that a unit vector in the direction of a particular given vector is always equal to vector divided by its magnitude. Alright, so now let us take an example. Let us say this vector A is given as 2i cap plus 3j cap. Alright, now if you are asked to find a unit vector along this given vector A, so the value of the unit vector along this vector A will be 2i cap plus 3j cap, which is the vector divided by its magnitude. Now for calculating the magnitude, you will obviously calculate the square root of the square of these two values. So square of 2 is 4 plus 3 is 9. The square of 3 is 9. So this will be 2i cap plus 3j cap divided by root 13. So all this we have studied in class 11th. But just a quick revision in order to recall what you have studied, because the unit vectors definition and concept will be required in this vector form of Coulomb's law. Alright, so I hope unit vector is once again clear to you all. If you find it difficult, you can leave a comment in the description section, and I will definitely have a video on this. Alright, now let us move on to today's topic, which is vector form of Coulomb's law. Now the study of vector forms of Coulomb's law is done in two ways, or you can say there are two different forms of vector form of Coulomb's law, depending upon the nature of the two charges where we are going to calculate the magnitude of the force. The first case which I have stated here is when the charges are of same type. Same type means the charges Q1 and Q2 are positive, or the charges Q1 and Q2 are negative. Alright. So the product of Q1 and Q2 in both the cases will always be greater than 0, because positive into positive is obviously positive, negative into negative is again positive. Alright. So therefore the product of Q1 and Q2 will be greater than 0 when we will have the charges of same type. Same type here means they have the same sign, the same nature. Now let us see how the force will act when the charges are of same type. So in this example I have taken Q1 Q2 as positive. Okay. So that is why I have not put a sign here. You can put plus here. Alright. Similarly I can replace this plus with minus minus. In both the cases the direction of F21 and F12 will remain same. Now pay attention. So the direction of force acting on 2, the second charge, due to the first charge, since the charges are of same type, so they will apply a repulsive force in this case. So direction of F21 will be away from Q2. Okay. Similarly, direction of F12 will be away from Q1. Okay. Now, when we write this in vector form, so 1 upon 4 pi epsilon naught Q1 Q2 upon R21 square and R21 cap. This obviously here is a unit vector. So the vector, as I said, force as I said, is a vector quantity. So it will have magnitude as well as direction. So this part of the formula gives us the magnitude. This gives us the magnitude of the force, and this gives us the direction of the force. Alright. Now let us understand how this direction of R21 is applicable in this case. So R21 here is a position of charge 2 with respect to 1. Position of charge 2 with respect to 1 is what R21 here is denoting. Now the easiest way to understand this is, suppose we have to find the direction of force acting on 2, that is the second charge due to the first charge. Now if suppose I place you here, suppose you are standing over here, standing on top of charge 1. So in which direction will you find Q2 moving due to force of Q1? Obviously in this direction. Q1 force की वजह से Q2 चार्ज किस डायरेक्शन में मूव करता हुआ दिखाई देगा? Obviously वो डायरेक्शन ये होगा, that is away from Q1. Alright. So this direction, that is towards right is taken as vector R21. This direction is R21. This direction is R21. So it signifies the direction. So this is towards right. Alright. So, and as we have discussed just now, that a unit vector can be written as vector divided by its magnitude. The modulus sign here represents the magnitude of the vector. So F21 can be written as, if I replace this unit vector by the definition of unit vector, that it is vector divided by its magnitude. So similarly, if you replace r to 1 cap, which is a unit vector, so it can also be written as r to 1 divided by r to 1. Alright. So in the earlier formula we have seen that the distance between the two charges is r. So similarly, that r can also be written as r to 1. If we talk about this length, then this length can also be written as r to 1. So don't get confused that what is this mod of r to 1. Mod of r to 1 is simply length of this vector. Alright. So I hope you have understood. I will repeat it once again. Force being a vector quantity will obviously have magnitude as well as direction. So by using Coulomb's law, we calculated the magnitude of the vector, which we discussed in the previous video, and in the vector form we also express the direction of this force. Alright. The easiest way to find the direction is, suppose we have to find the direction of force acting on the second charge due to the first charge. So assume that you are placed on top of the first charge. In which direction will you find the second charge moving because of the force of the first charge, the electrostatic force of the first charge? So obviously these charges are of same type, because Q1 Q2 is taken here as positive. So the force will act in this direction, towards right. So towards right I have taken as positive. This direction I have taken as positive. Alright? Clear? Similarly, you can express the value of F12 as well. Now, if you are asked to express the value of F12, what changes will occur in the formula? That also you can understand quite easily. Now, suppose we have to find the value of force F12. So, this will become 12. And now the unit vector here will also change. So see what changes will be there in the formula. Now the direction of F12 will be towards left. The direction of F12 will be towards left. We have taken as R21 as positive. Towards right, this direction we are taking as positive. So अगर हमें R21 का direction mark करना होगा, which will be in this direction. This will be the direction of vector R21. अब इसको कैसे find करेंगे? Now, I told you the way to find this. Assume that you are placed on top of the second charge. In which direction will you find Q1 moving? The direction in which Q1 will move because of the force acting due to Q2 will be towards left. Alright? तो ये direction towards right अगर हमने positive लिया है तो towards left क्या होगा? Negative. So if I am expressing this in terms of R21, so I have to write minus R21. This is direction R12. Alright? And I have to write minus R21. Clear? Because R21 का direction towards right था, जो कि positive था, but R12 का direction किधर आ रहा है? इस तरफ. So you can express this as in vector form. Direction of R12 is opposite to that of direction R21. Clear? Alright. Now let us move on to the second case. The second case of Coulomb's law is when charges are of opposite type. When charges are of opposite type, then obviously the product of the charges will be negative. Opposite type means if one charge is positive, the other one is negative, or the vice versa. This may be negative, then Q2 will be positive. Now the force acting on the charges in this case will be opposite to that of the previous case. Now suppose you have to write an expression for F21. F21 is force acting on the second charge. Force acting on the second charge due to the first charge. So force acting on the second charge due to the first charge will be given as 1 upon 4 pi epsilon Q1 Q2 upon R21 square. Clear? This part again gives us the magnitude of the force, and this unit vector signifies the direction. As already stated in the previous case, that the direction of R12 is towards right. तो ये डायरेक्शन अगर पॉजिटिव है, so as you can see in this case, what is the direction of F21? F21 का डायरेक्शन किधर जा रहा है? Towards left. तो ये वैल्यू क्या होगी? Negative. So this direction in this case will be towards left. This is R21. R21 का डायरेक्शन इस तरफ जाएगा, which is negative. Alright. So अगर left side का डायरेक्शन है तो वैल्यू नेगेटिव होगी, और अगर राइट साइड में है then the value will be positive. Clear? So you can understand very well what exactly does the Coulomb's law, vector form of Coulomb's law, explains. Now in board examination you might be asked to state vectors form of Coulomb's law. Then you have to draw this diagram and write the magnitude and the direction. Only the expression is required. Now one very important point which you have to make a note of is while solving numerical questions, while solving numerical problems, you are going to apply simply the Coulomb's law. Alright? While solving numerical questions, you will simply apply Coulomb's law, and for finding the magnitude, of the force, you will simply apply Coulomb's law. और डायरेक्शन के लिए, for finding the direction of the force, you only have to keep in mind that like charges will repel and unlike charges will attract. So this is for numerical questions where we will be asked to calculate force due to Coulomb's law. There you need not bother about applying the vector form of Coulomb's law. numerical question solve करने के लिए सिर्फ ये दो चीजें जरूरी हैं. पहला magnitude of the force which you can easily calculated by applying Coulomb's law. दूसरा direction of the force can easily be find by applying the concept that the like charges repel and the unlike charges attract each other. For example, let us assume that we have three charges A, B and C. The value of the forces is given as 1 microcoulomb, this is 2 microcoulomb and this is minus 3 microcoulomb. And in the question you are asked to find the resultant force acting on B. Resultant force B पे कितना लगेगा ये फाइंड करना है. Alright. So in such type of questions where you have to calculate the value of the force. And obviously that force being a vector, you have to consider direction. So don't get worried about applying vector form of Coulomb's law. We can simply apply the Coulomb's law for calculating magnitude, and for considering the direction part, you can keep these 2 points in your mind. So let us do this problem. Force acting on B. So there are 2 charges surrounding B. One is A, the other one is C. A is a positive charge. A is a positive charge. So A positive है, B भी positive है, तो दोनों के बीच में force of repulsion होगा. So direction of force on B due to A will be towards right. B पे लगने वाला force A की वजह से, because A B positive, so like repel, so this will be towards right. Direction of force acting on B due to C. B positive, C negative. So direction of force acting on B due to C will be towards C, because unlike charges, A positive, A negative, they will attract each other. So since FBA, FBC are in same direction, so we will simply calculate their magnitudes by applying Coulomb's law, and we will add the 2 values to get the final answer. And the forces FBA and FBC both are directed towards C. So for the direction part, we will simply write that the resultant force on B will act towards C. I hope the topic is clear to you all. In the next class, we will start with electric field lines, their properties and their different cases.